This is the second video in a series of 3 presenting the paper Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. The authors of this article include members from the Intelligent Hardware Research Group at Beirut Arab University in collaboration with Professor Hussein Mouftah, the Canada Research Chair in Optical Networks and Distinguished University Professor at the School of Electrical Engineering and Computer Science at the University of Ottawa. Another taxonomy was presented in the article, which showcases the performance metrics used in the literature. These ITS machine learning and hardware indicators are either complexity or competency indicators. ITS indicators included vehicle and traffic efficiency, energy, operational load, infrastructure and deployment scale, data, node resources, and safety services. Hardware indicators included frequency, area, power consumption, memory capacity, interfacing capability, and time factor. Finally, machine learning indicators included complexity, accuracy, scalability, time factor, robustness, additional needs, and additional abilities. All ITS indicators count as complexity indicators, and all hardware indicators count as competency indicators, while machine learning indicators are split between both. For each set of indicators, levels of performance from low to high were set based on specific sub-indicators for each indicator, as part of a performance evaluation model. For example, vehicle and traffic efficiency is an ITS indicator, and its performance levels are as follows. Low average travel time, short queue length, and few congestion occurrences qualify as low complexity for vehicle and traffic efficiency. Moderate average travel time, moderate queue length, and some congestion occurrences qualify as moderately complex vehicle and traffic efficiency. Finally, high average travel time, large queue length, and many congestion occurrences would qualify as highly complex vehicle and traffic efficiency. The proposed levels of performance of one hardware indicator, the area, are as follows. A small number of computational units counts as low area, an adequate number of computational units counts as mid-range area, and a large number of computational units counts as high area. It is important to note that some of the hardware metrics of this evaluation model vary among different devices. For example, the area is expressed in CUDA cores for GPUs, logic slices for FPGAs, and general-purpose processing cores for computer boards. The overall complexity of an ITS application and a machine learning technique, as well as the competency of a hardware device and a machine learning technique, can be individually determined using a specific scheme for each. For instance, the authors developed one competency scheme and one complexity scheme for machine learning techniques. If most competency indicators are high and none are low, then the machine learning technique is considered to be highly competent. On the other hand, if most complexity indicators are in the mid-range, then the technique is considered to be somewhat complex. Next, a cross-matching evaluation chart that aims to deduce the recommended competency of the machine learning technique and the hardware device to be utilized for a certain ITS application was developed. To determine the machine learning competency, two indicators were singled out, which are data and operational load, for their importance. These ITS indicators encapsulate the volume and type of data the machine learning model has to deal with, as well as the response time expected from this model. Combining the level of these indicators with the level of the ITS complexity can help us determine the desired machine learning competency, which can be easily mapped out to the corresponding machine learning complexity. Then, to determine the hardware competency, the infrastructure and deployment scale, as well as the node resources indicators, are also singled out to be used along with the machine learning complexity level to determine the hardware competency. This cross-matching evaluation chart aims at ranking machine learning techniques and hardware devices that promise a certain level of performance per ITS complexity. With this, we come to the end of the second video in a series of 3 presenting the paper titled Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. The link for the previous and upcoming videos are in the description section below.